Alright guys, Simon here, and an update on my Pentominoes program. We're up to version 0.22. It took a while longer than I expected because the thing there was a bug with something. Not with my program, but with Flash. So it kept crashing until I deleted the border. I don't think if you can see it, like around the border of the program there's like a white rectangle. In Flash it's just a rectangle, but that was causing it to crash, so I deleted it and then redrew it, and then it worked again. So that went on for a few weeks, and so I didn't actually make as much progress in this as I would have liked. But so this is the last one. This is the new one. Most of the changes are graphics, and the other change is that before, when you flip it, it would flip along a local axis. So if it's, when you flip it, it's horizontal. You're flipping horizontally, right? But then when you rotate it, it would flip vertically because it's on a local axis. Because you rotate it, 90 degrees, then it would flip vertically. So now it flips horizontally regardless of how you rotate it. So I've got the old one here. So if you pick that up, see how it flips horizontally, and then I rotate it once, it will flip vertically. So that was a bit odd. So I've changed that to that. I mean, that's such a minor change, right? But I changed that, and also what did I add? And also, I guess the major mechanics change is that the game now recognizes a victory condition. So if you actually solve the puzzle, let me just quickly do this. If you actually solve the, and I mean, I don't know how you guys feel about these graphics. I mean, I don't have, an option for different, graphic style yet, but I've chosen a brushed steel on a felt table kind of thing. So now it knows when you've solved the puzzle. So you put all the pieces in here, it says puzzle solved, right? So those are the major changes. I mean, it seems pretty minor, right? But as I said, the Flash kept crashing on me, so I didn't make much progress. But now that that's done, I can quite easily change the puzzle. I mean, use the same pieces, use the same kind of mechanics, but change the victory conditions. So I have a different shape here, and then you can fill that shape in, and they'll recognize that. Or I can quickly make it so that it'll recognize that. So I can make a whole series of these puzzles, and they'll all work fine, basically. So this sets me up to create a more interesting game where instead of just one puzzle, you have a series of puzzles, and you can kind of have a simple ones at the start, and then have more complex ones later on. So that's basically it so far. So I don't know what else to say really. So I'll put the link to this. This is the link if you want to type that in. But I'll put the link to it in the video descriptions if you guys want to have to play with it. And I'm pretty sure it works. I mean, it's Flash, right? There's not much compatibility issues. But just see how you feel about it, and if you have any comments. Alright, so let's go into some details. You don't have to watch anything else if you're not interested in coding. But as before, I put all the code here. Let me see. So let's go through the code. So most of the stuff is the same as before. Puzzle bounds, puzzle board. Oh, the other thing. I almost forgot. So here the pieces, they dock, on screen. So you pick up these pieces directly. Here I've made it so that you pull them up from these buttons, right? And that's basically just to save space and to reduce clutter at the start of the game. So imagine that piece is back there. So it reduces clutter. It reduces some clutter on the screen. When you first start off, and just makes it a bit cleaner and easier to manage. And you don't have pieces on there. So if you want to just kind of arrange the pieces your own way, it's easier because there's no other things in the way. So that's the other major change. So that's not just graphical, that required a little bit of coding change. And the way it recognizes the boards, you can kind of, if you pull the piece onto the edge, it won't actually slide off the edge, and then when your mouse moves off the flash thing, it will just drop the piece. And that's kind of important. I don't know if you guys think that's important, but I've played a lot of games where if you're clicking on something and then you slide your mouse off, it has weird behavior. And so I've made sure not to, have that problem in this game. So you see that it just kind of slides along the edge. You can't actually pull it off the board. And when your mouse moves off, it drops it. Whereas I've seen some other games like if you do that, the piece will keep following your mouse off the program, and then it does weird things. So make sure make sure that works. Actually, what happens if I do this? Yeah, it drops the piece. Okay, I see. But you see here, like when I move the mouse towards the edge, it doesn't stop. Now you see, you can see, like, visually it slides off the page. I mean, it kind of slides off the board, and then when your mouse moves out, then it kind of just jumps back. So that's a little bit strange. You can see how that's a bit strange there, right? So we avoid that. And also, the problem with having these things on the screen is, I think I explained it last time. So imagine if I kind of move these pieces around, move those there, and move that there, and then if I kind of drop this piece onto another one, I've made it so it doesn't overlap. It will go back to its docking position. But now the docking position is already occupied by the other pieces. So then you've got this overlap, and then you can lose the piece. You don't know where it is. So that's what I'm trying to avoid here. Right? So imagine if it's like that, and then you just kind of, hey, where'd it go? Gone. So the overlapping thing is still a problem here with the old program. So by having these buttons down here, and then moving them back into the button, as it were, then we avoid that problem. What's really happening is they're moving off screen, and then the button just changes. But it looks like they're moving into the button, which is kind of funny. Right, so there's a bit of change in the code here. So the puzzle bounds and puzzle board, I think back here there's only puzzle board. Oh no, there's only puzzle bounds. And so that's why, and that's the whole thing. So that's only for me to detect if the mouse is outside of the puzzle. Whereas here, there's the puzzle bounds, which is the entire board, and also the puzzle board, which is a bit strange. The variable names aren't very well done, I know. But the puzzle board is you see how this piece kind of slides along the edge there? That's the puzzle board, so it stays inside the board area, but the mouse is still technically in the program, right? But when the mouse moves out, then it's outside the puzzle bounds, and it drops the piece. So there's two borders, right? There's one border for the mouse cursor, and then there's one border for the piece. You see how that works? So I've added a variable to allow that to happen. That's all the same. So now this variable solved 12x6. So that's just the name of, because this puzzle is 12 squares by 6 squares. So that the name of this puzzle is 12x6, 12 by 6. So at the start of the program, it's false, so it's not solved, right? And then here we have some arrays, the puzzle target X array and the puzzle target Y array. Basically, there's these 60 numbers. That's the X coordinate and that's the Y coordinate. And these are just these squares. So the location of those squares. So then we're defining for the program the squares that need to be filled in order for this puzzle to be solved. Well, I mean, if we understand it that way, the program doesn't really know, right? So that's the puzzle target, which is the shape that you want to fill with the pieces. And then the pieces to win, 12 pieces to win. And I made this kind of separate because by doing this we have the option of not filling the whole thing. So imagine if I change this to like 1. If I change this to pieces to win to 1, but then the puzzle target is still all those numbers, then I just put one piece in and it'll win the puzzle, which is a bit odd, but it just means that it allows me to define puzzles where you don't actually have to fill the entire puzzle. You can just kind of fit a few pieces in, or fit a few pieces in, and that will solve the puzzle. So it gives me a bit more flexibility in designing these puzzles. So pieces to win is 12. So for this puzzle, you need to put all 12 pieces into that rectangle in order for you to win, right? And then the other stuff is the same. So pieces, parts, there's kind of 5 parts per piece. Actually, did I have that back here? Let me just... I'm sure I have, yeah. So there's 5 parts per piece. So again, we're playing Pentominoes. So there's 5. So each of these is 5 squares. So 1, 2, 3, 4, 5. And then this one's like 1, 2, 3, 4, 5. So I can, if I change the piece parts, the number of parts per piece, to like 4 to like 6, then I can design a different sort of puzzle. So the code is I made it flexible if possible. So the other stuff is pretty much the same. I don't know if I want to go through all that again. So there's a lot of arrays for the positions and rotations and everything else. So we don't need those things. So all this stuff is old. Let me just double check. So all this stuff is, so this stuff is the same as the last one. So we don't really need to talk about that again, I don't think. What's this one? This is put down. Nope, not interested in put down. Oh, so when you put down the piece, at the end of that function, it checks victory. So it calls the check victory function, which checks if you've solved the puzzle, basically. So whenever you put down a piece, it checks to see if you've actually solved the puzzle. Alright, the rotate one. So here, like if the flip key is pressed, then you rotate it. Although this is the flip one, then you flip it. But so instead of telling it to flip horizontally, it still flips vertically. It flips vertically and then rotates. If that makes sense. So actually, how do I explain it? So here, so if it flips it flips along, that axis, and I rotate it once, and then it looks as though it flips along this axis. But telling the program to flip a piece along two different axes is kind of complicated. So what really happens is, so here it flips along that axis. It flips along the vertical axis. What happens is when I rotate it and I press flip, it actually flips it vertically. Actually, let me just show you here. Actually, so if I do that, it actually flips it vertically and then rotates it twice. Does that make sense? So here, you should end up with that. So it flips it along the local axis still, but then it also rotates it 180. So it looks like it's flipping along the other axis, when in fact it's just kind of flipping the same axis and then rotating. So visually, it looks like it's flipping horizontally all the time, but in fact it's just flipping along at the local axis and then rotating for you. But you can't see it because it does it immediately, right? Anyway, that's not too important. But that's how I did it, and it makes things a little bit simpler for me. Check overlap is the same function as before. Part coordinates is the same function as before. It's just, did I explain it? Yeah, basically it gets the coordinates of the parts of the pieces and allows you to check whether they overlap. So check victory. So this is a new function. Let's see, variable part coordinate 1. Alright, so these are just working variables. So we're getting, the coordinates of each part of each piece to check if they're inside the puzzle target area, right? So that's just to get a part of a piece for that variable for the checking. Pieces on target, so how many pieces are actually in the target area? So at the start of the function, we just reset it to 0. And then for every single piece, so there's 12 pieces in the Pentominoes. So pieces length, that's how many pieces there are in total. So for every single piece, we set the working variable to 0. So the pieces on target, actually no, this is the parts on target, sorry. This is the pieces on target, this is the parts on target. So parts are part of a piece. So how many parts of that piece is on target? So reset that to 0 here. And then for every part of each piece, and piece parts is 5 for Pentominoes. So there's 12 pieces, and then 5 parts for each piece. And then for every puzzle target coordinate, there's 60. Actually, no, there's 12 by 10. There's 12 by 6. Sorry, my bad. That's 60. Sorry, yeah. So there's 60 squares in the puzzle target. So you have to kind of fill all 60 squares with pieces. So for every puzzle target coordinate, so there's 60 of them. So part coordinate I and j. So you get the part coordinate of piece I and part j, so from 1 to 12, there's 12 pieces, and then 1 to 5 parts for each piece. So you get the coordinate of that, and you just kind of put that in part coordinate 1. And then if the x coordinate of the part is the same as the puzzle target number k, remember there's 60 of them, so there's from 1 to 60. So if the x-axis is the same and the y-axis is the same, then that part is on a target area or on a target coordinate, right? And we increment parts on target by 1. And then we go through that 60 times, and by the 60th time, if the number of parts on the target is the same as the number of parts per piece, which is 5, then the number of pieces on target increments by 1. So, does that make sense? That seems kind of complicated. It makes sense if you're a programmer, I guess. So for every piece, and then for every part of every piece, we check if that part is on a puzzle target. And if it is, then we increment the number of parts per piece, or we increment the number of parts on target. And then after we've gone through all 5 parts, if there are 5 parts on target, then we increment the number of pieces on target by 1. And then at the end of that, once you've gone through all 12 pieces, if the number of pieces in the target area equals the number of pieces required to win, then the puzzle is solved. That's this part here, puzzle solved. So I hope that makes sense. Basically, it just checks if every part of every piece is inside the puzzle area, and if it is, then it's solved. Basically, that's what it means. The other stuff's not too interesting. So we need more event listeners, because what happens is we can pick things up. We can pick up the pieces directly, but we can also pick them up from the buttons, which are called drawers. I don't know why why did I call them drawers? They're kind of kept inside drawers. That's just really strange variable naming conventions. So you can pick the piece up by the piece itself, or you can pick it up by the button, basically. So we need more event listeners to listen for events on clicking those, and then everything is done there. That's the old stuff. So at the end of the first frame, there's still this stuff. This is new, initializing the puzzle, because what happens is resetting the puzzle requires us to put all the pieces back into their docking positions. So at the start of frame 1, at the end of the program with frame, but at the start of the game or the program on frame 1, it puts every single piece into its docking position, and it resets the rotation and the flipping. So it just kind of puts every piece back to its original position. Before I didn't have this, because when you first run the program, it just kind of loads that from the file. So you don't have to do this manually, but because I'm having the reset puzzle thing, which allows you to reset the puzzle, then we need to do this. We need to tell the program to do this, to reset it, right? And it makes everything, it makes the upper layer invisible and everything. Alright, so basically that just kind of resets the whole puzzle. Frame 2 is pretty much the same, except frame 2 is mostly the same, except that if the puzzle has been solved, remember the check victory thing. If you've actually solved the puzzle, then it sets that to true, right? So if that variable is true, which means that you've actually put all the pieces into the puzzle target, then we're jumping to frame 4. Otherwise, it goes to frame 3, and then it jumps back to frame 2. So it runs frame 2 over and over again until we solve the puzzle, and then it jumps to frame 4. And frame 4 is basically just the victory screen. And all it has is a reset button, and the reset button, if you press that button, it goes back to frame 1. And remember, in frame 1, there's this stuff at the end which resets the puzzle. So frame 1 is all the functions. It defines all the variables and functions that start the game. And then it goes to frame 2, and then it just kind of keeps looping back to frame 2. And this is you moving the pieces around and then dropping them, right? And then it's checking for overlaps and stuff like that. Actually, it's not here. Checking overlap is... Anyway, it's somewhere around here. So this is you moving the pieces around, but if you win, then it jumps to frame 4, which is the victory screen. So right now we're looking at frame 2. Frame 1 you don't actually see, because it just does that quickly and then it goes past it, right? So when we solve the puzzle, let me just do this. And right, so once we do that, so this is frame 4, and you know, I've made it so that we make the buttons darker and everything else is nothing happens. So frame 4 you can't pick these up anymore. Actually, how did I... oh, that's right, yeah, frame 4 you can't pick these up anymore, because this only happens... well, that stuff only works if it's from frame 2. So here, see here? If the pieces are grabbed, then then it follows the mouse. See that? If the pieces equals mouse X. So this is these are the pieces following the mouse, but staying within the puzzle area. So that's what these are for. So that's on frame 2. Because we're not on frame 2 anymore, these pieces don't follow your mouse, so you can't actually move them. The only thing that works on frame 4 is this button, which resets the puzzle. There you go. So the victory screen is not defined. I mean, it's not complete. That's just there as a placeholder. What happens next? What I want to do next is, so this is not the start of the game, I guess. So I guess at the start we have like a title page, and then like a level select. And I don't know how many levels, I don't know, but then you click on a level, and then you go into one of these things, and then most of this will be the same, but this will be different. So the puzzle target will be different, but everything else will be the same. And those will be different puzzles. And then at the end of the puzzle, you can either repeat the puzzle or just kind of go back to the puzzle, like go back to the level select screen, right? And I think that will be the end of the game. I mean, that will be the end of the design of the game. Basically, just this, except have multiple puzzles. I just want to keep this simple. I mean, I can make things fancy, but I want to keep this simple for a start. Oh, actually, you see this here? Z equals rotate, X equals flip. I'm thinking I want to put that around the piece too, just to make it more visible and more obvious. So have like Z to rotate and then X to flip, and then just have that follow the piece around so you can always see it. Otherwise, this might be a bit too subtle. I'll leave that there, that's the title of the game. But I might put that so that whenever you're holding a piece, then it shows on the screen how to rotate and flip it. So that's another minor visual change. I might do that first. Actually, I should do that first. And then I'll design the different puzzles, and then I'll design the puzzle select screen. So the different puzzles, in order to do that, basically I have to redraw this. So this will be a different shape. So I'm just going to draw different rectangles on screen. And then I just change the corresponding numbers here. So the puzzle target, I just change these numbers. And if necessary, change pieces to win. So if it takes less than 12 pieces to fill the puzzle, then I change that number. So what I do is I change these numbers, and I change this variable to give it a unique variable. And then that will be a new puzzle. And then everything else just stays the same. So I don't need to change anything else. I just need to change like that stuff there. Just a few numbers there, and then I just have to redraw a grid, and that gives me a new puzzle basically. So the way I've written this program, I can just kind of make new levels fairly easily. Is that everything else I have to say? Yeah, I think that's pretty much everything I have to say. So if you want to play with this thing, go ahead and go to that link. It's in the video description. And tell me what you think. I think the visuals are okay. Again, I don't want to spend too much time fiddling around with the visuals, because that's fairly easy to change. They're bonus things. Like the basic game is functional enough, right? The basic game is working. Oops, is working as intended. So everything is kind of pretty much done. Like the extra stuff, I don't want to spend too much time on. It's not too important. All right. On a different note, I'm not using XSplit anymore, because remember last time we used XSplit and they put a watermark around here. So I'm using Open Broadcaster software. Whoa, Inception. We're using Open Broadcaster software. It saves this directly into a MP4 file.